M6C4 homework 1-2, question number 12, a difficult question. Following on from question 10, at a nucleon separation of 1.8 femtometers, the resultant force of attraction is minus, which means it's an attractive force overall. So it's a resultant, so that's our repulsive force, which would be a positive force, added together with our strong force, which would be a negative force. And if the resultant force is negative, that means the strong force is winning. Calculate the strong nuclear force acting at this point. We can't calculate the strong nuclear force, so we will likely be using Coulomb's law in order to get our answer here. So I'll write Coulomb's law ready to go. Q over 4 pi epsilon naught r squared. And I'll start filling in the numbers, but then we'll have a look at the graph in just a second. So this is identical to all the previous questions. Here's the charge on our 2 protons, 10 to the minus 19 divided by 4 pi times 8.85 times 10 to the minus 12 times by, now the distance I can just use the one that's given to me in the question here, so that's going to be 1.8 femtometers, so open brackets 1.8 times 10 to the minus 15, close brackets, don't forget to square it. Okay, so that sum there is going to give us the electrostatic force of repulsion, the positive part of the two forces that are acting on these two nucleons. But if we go back to the original graph and have a look at what's happening at this 1.8 femtometers, so long story short, it looks as if it's talking about that particular point there, which lines up with 0.05 kilonewtons. Okay, that fits in perfectly with what they're telling us here. That is the same as minus 50 newtons. So that means that the strong force is 50 newtons bigger than whatever the electrostatic force of repulsion is. So whatever this answer is here, in order to work out the strong force, you would just need to take that answer, so whatever that answer is, and add 50 newtons to it, and then that would be the answer to this question. Therefore, when you get these two forces added together, this one is a negative one, this one is a positive one, and then when you add them together, this one has a slightly bigger magnitude, and so therefore this will give us a overall force of minus 50, hence why that point on the graph is in the negative.